Welcome back. This is the very first video that we're going to do in Chem 175, and the topic for discussion is colligative properties, as you can see on the title of the video. All right. Now, this is a very large topic, and to teach you everything about colligative properties in one course is probably not enough time because we have to learn other things. So in lieu of time, and then to keep every video less than 10 minutes or so, I'm only going to focus on certain key conceptual concepts, and of course, we're going to back it up with some mathematical problems. But here's what I want you to take away from this topic of colligative properties. It's not just about you being able to solve some math problems, because even if you can, at the end of it, you would still be wondering, why does it matter? Why do I have to know how to do these problems? Or what's the larger implication of these concepts? Well, with that said, many of the things we do in our daily lives or will do in the future, or we may never do, require some understanding of chemistry, at least at the very conceptual foundational level. All right. And one of the concepts is boiling point. And if some of you are outdoorsy and you like to trek and go to colder regions as part of your hobby, then this question would be much more pertinent. But then it will also be pertinent to people living in higher altitudes that doesn't necessarily have to go hiking or any of that stuff. So what happens to the boiling point of water at higher altitudes? Does water boils differently in Denver in higher altitudes than it is in, for instance, Lexington, Kentucky? Does water boils faster at higher altitude? Does it take longer to cook food at higher altitude? Do I know the answers to these questions? Of course I do. And I want you to be able to find some answers to these questions, either through the videos at the end of this topic, or if you really like the topic at the end of it, maybe you'll do some search and find some answers to these and share your ideas with the rest of the classmates. All right. Now, with that said, the second topic for discussion is melting point. Why can't we just add sand? Now, some of us live in regions where, like in Kentucky, we do get snow, we do get freezing conditions, and sometimes it's very sub-freezing conditions. And why can't we just add sand, sawdust, or sugar when freezing conditions persist? We're just looking for traction, aren't we? So sand, sugar, or sawdust, or any other form of solid should work, right? But we particularly add salt, and I think anyone that's living in colder regions would be accustomed to the idea of salt being thrown on streets. Now, there's another term that you may not know from your other science experience, or some of you might know, is vapor pressure. And how does the idea of vapor pressure plays a key role towards boiling point, and how does that answer to the three questions above under boiling point, or the questions just shown below? If some of you are going to carry over into my organic chemistry coursework, where you would synthesize fragrant oils as part of the lab experiments, and some of you might synthesize oils from spices like cinnamon, cardamom, cloves, caraway, or from citrus fruits like orange, lemon, or flowers like maybe rose or lavender. So steam distillation is a process that avoids any chemicals being used to make these fragrant oils and makes them pure and without destroying them. And it's a convenience that you can do steam distillation. And to do that, you need to know a lot about vapor pressure and boiling point. And in the process, you may want to know the term azeotrope, something you may not want to know now, but in future, near future, you may want to know what is an azeotrope and why does it play such a big deal towards steam distillation of fragrance oils. All right. With that said, this is kind of the conceptual outlook on the concept of colligative properties. Of course, you might be able to do some math problems, but if you don't have these basic conceptual knowledge behind the math problem that you might solve, then you're just merely being a technician trying to solve some problems, and it really is not a big deal, right? So if you get out of my class and you don't know the answer to like It's a common question. You go on any blogs, you will see questions like, does water boil faster at higher altitude or stuff. Now, if you learned my class and you know the answer to these questions, you look much more, wise, and that's a good thing. Now, colligative properties, as I said, is a large topic, and there are four fundamental concepts that we will learn in this class to understand colligative properties. And this covers all three phases that you all know: gases, liquids, and solids. And how does a gas influence into a liquid, a solid influence into a liquid, or a liquid influence into a liquid? And you can think of other combinations. But ultimately, there are four major concepts. One of them is vapor pressure. Other is elevation of boiling point, depression of freezing point, and osmotic pressure. Now, if any of you going to take MCAT or any of the pre-professional exams, you'll definitely be guaranteed to see some of these questions on those exams, which be most likely either a math problem or something more conceptual like you see under my major questions. All right, so with that said, I want to not actually commence the entire topic in this particular video, but actually take the time to get you up to speed to, all right. So some of the words that you should already be familiar with Chem 170, which is a class you took prior, before coming into this classes, you should know what a solution is, what a solvent is, what a solute is. How do you find the mass of a solution, which is mass of a solute, and mass of a solvent? And of course, you've done enough, at least bare minimum problems to know what molar mass is. And the two major concentration units that we learned, which is molar concentration or molarity, and molal concentration, also known as molality. Now, these are terms that you cannot just forget from 170, thinking 175 is going to be a completely different ball game. Well, it sure is. It's a little bit more complex. But the reason we spent a considerable amount of time getting you prepped up for this course is that, that you have the foundational knowledge engraved in you through these terms. Now, there's a couple of terms that will be new, but again, we are going to learn them in this particular topic, and that is I'm going to delete this after I get rid of it. I'm going to bring it back in a different screen because I don't want it to blind the equations there. So mole fraction is a term. We all learned about molality, where we find moles and divided by the molar mass of divided by the mass of the solvent. This is kind of along the same logic, mole fraction. Now, if you're trying to find the mole fraction of the solute, I have briefly taught you this in 170, but we didn't do enough problems around it for you to concretely know. So that's why I'm bringing it back. Mole fraction of a solute is moles of solute divided by moles of solute plus moles of solvent. So obviously, you'll be given mass of each of those. And knowing the molar mass, you can find the moles of the solute and the solvent. Mole fraction of the solvent would be just merely moles of solvent over moles of solute plus moles of solvent. And the other key term is partial pressure. Okay, that's a term that you may want to get yourself familiar with it. Now, I'm going to take this piece out of the video here, and then we're going to bring it back in a different context when we might actually do a problem. At this point, we don't really need this piece of information. But the reason I'm putting it here is so you know that you need to be familiar with these terms, right? Okay, so with that said, so we're going to detailedly look at, I'm going to spend very little time on each video just to make things more interesting and not give, a lot of information per video. So we're going to discuss each of the various concepts listed above, such as vapor pressure, boiling point, freezing point, osmotic pressure. And like I said, hopefully at the end of learning this entire concept of colligative properties, and then you might be able to answer some questions to the idea of that I posted here, or at the end of maybe intermolecular forces or kinetic theory of gases, something we'll learn next up. Maybe you would you would find some answers to these questions. Okay, these are not difficult questions, but they're not straightforward. They do require a little bit of thinking. So I'm going to stop this video at this point for this one, because this is merely introducing what is colligative properties. I don't think I've even defined the term colligative properties yet, but these are things that you may want to know as you walk into the world of colligative properties. All right, so I'll see you back with a video on vapor pressure, which is the first item on the list. So stay tuned.